Okay, say if you need more time. Okay, I guess we keep moving. So what we do, we import the data, and I remember actually a student last year uh, come up with a code how to make all variables numeric and not to do it manually. But there is a thing we need to keep state variable as character variable. So I can give you extra credit if you can figure out how to modify this code to make one specific variable character. So we run this code. And we do what we did before, making it panel data. And again, like just to, this is not panel data, right? And if you look over here, it became a panel data. Okay. Go away. Yeah. Okay. So let me explain you a model with interactions. So the way you run your model with interactions, and for model with interaction, at least one variable must be a dummy variable. Otherwise, you will have a hard time explaining the results. So we have like our usual, and again, like get rid of scientific notation always. And again, we have the variables we used before, like premiums, inflation adjusted, post variable, which is again zeros for time period when Trump policies about short-term plans have not been in effect, and ones when Trump policies regarding short-term plans have been in effect. But then we are going to include interactions and we have a bunch of control variables like share of young adults imputed, uninsured rate in 2017, median state income. And the way we do interactions is first we have variables. In this case, we have variables for state policies regarding short-term plans, and states they adopted different policies, and there are like a bunch of there are a bunch of there are a bunch of policies. Some states, like I don't know, Alabama, they allowed short-term plans to be 36 months, which is like 3 years. I think one state, Kansas, allowed short-term plans to be 24 months. A bunch of states allowed them to be 12 months, and a bunch of states allowed them to be 6 months, and some states banned it. And important thing is some states allow short-term plans for 3 months, but when you run model with interactions like this, you leave it out as a reference category. You're going to compare your results, your coefficients with this reference category. And in this case, it is plans which have short-term plans for 3 months. And again, let me show you how it works. Uh, okay, that. Yeah, okay. So, do you guys see the data set? Yes? No? Or you do?
Yes, I can see it.
Okay. So, the way you set up this kind of analysis And you see, okay, we don't have like states, but I think the first one is like Alaska, Alabama. So in Alaska, Alabama, you see once, it means that they allowed short-term plans to be 36 months. But then when we look at other variables for duration of short-term insurance, we have zeros for like Alaska and Alabama, because again they had different policies. Their policy was allowing short-term plans to be basically 3 years. So the way you set up difference and difference analysis is, and again, difference and difference analysis, interaction stuff. It's a quasi experiment. It's like a way to do an experiment where um, you have some kind of change in policy at particular point in time. In this case, 2018, when Trump started implementing his policies regarding short-term plans. He passed a bunch of regulations. And then in some states um, um, embrace this policy, but some states, like again, uh, like blue states like New Jersey, California, they just ban short-term plans altogether. So the way to set up analysis is have your variables, but then have interactions. A post, remember, post is one more time. Oops. Post is a variable for Trump, right? So what we are doing and what's happening in like in real life, you have interaction of federal policy with a particular category of state policy. So let's run the model. So in this particular case, 40, and we are interpreting adjusted R square. Can somebody interpret adjusted R square? Ben, could you please do it?
Yeah, so with an adjusted R squared of 0.456, a little bit less than half of the variation in the
Premiums,
the premiums is explained by these uh what is that?
independent.
10 or so
Yep,
variables plus five I don't know how you refer to that. Uh Five, I guess, interaction variables.
yep. So, and when you guys interpret it in in your problem sets, you need to be like really specific. You just say um, like 45.6% of change in premiums is explained by independent variables in the model. You just give like percentage. And think about difference in different models. In those models, you don't care about like control variables. In different models, what you do, you only interpret your interaction models, your interaction variables. So, can somebody say if interaction variable of state policy of like banning short-term plans and federal policy, is it statistically significant or not? What this p-value indicates? Is it larger or smaller than 0.05? Okay, we have an answer in chat. Yep, so it is statistically significant at, let's see, yeah, at 95% confidence level. And the way you interpret this result is, and again, when you interpret it, you make a comparison with reference category. And in this case, and the way you set up reference category, you exclude it from analysis. So in this case, it means that premiums in states that banned uh, short-term plans have been lower by $94 since we know how premiums are measured, right? By $94 than in states that allowed them for 3 months. And then another statistically significant interaction variable is that uh, uh, premiums in states that allowed short-term plans for 6 months have been lower by uh, $73 than in states that allowed them for 3 months. So this is how you do interpret interactions. And let's actually add uh, this stuff. Okay, oops. So what I'm asking you to do, you just like follow me. Open the file from previous class and let's check for heteroscedasticity. Oops. Okay, let's see. Okay, the model, we call it P1 and it's also P1. So we don't need to do anything. We just click and run it. So how we interpret this plot? Do we have heteroscedasticity? Can somebody tell me? Guys, we have done this before a bunch of times. Ben, could you please help us?
I
Okay.
can give it a shot, I guess.
Yep, yep.
So this sort of residuals graph, it doesn't have the some of the weirdness that we've seen on some of the stuff we've done in class. Partly just because there are a ton of variables, so everything's a bit more distributed. It does look like the residuals tend to increase as we increase in the premiums. Or the at least the variance tends to get wider,
Mm-hmm.
which may be an issue.
Yep, yep,
But it also looks like the bulk of the data is clustered at pretty low residuals.
yep,
So
yep.
it's not too bad.
Yeah, but it's not perfect. This check for it's not that. Yeah. Okay, and now let's do a multicollinearity check. Again, we just go back to Kostyrev linear regression multicollinearity. We copy paste it into this. Oops. And again, since our model is the name is P1, so we just run it. We don't need to do anything. Oops. Oh, that's interesting stuff. So, what about this? What about this variable? I am pointing at it. Share of young adults imputed. It has the value of 39. Do we have multicollinearity issue? And over here, this is how you interpret it.
Two of these fields have pretty bad
Yeah,
correlation, which means they're probably correlated with each other, if I had to guess.
yeah, yeah. And this is the reason why my paper was published. It's not the whole model. My whole model is a bit more complicated. But when we submitted this paper to uh, based on this data set to like very top journal, we got a desk rejection saying that your model has a multicollinearity issue, and basically we got rejected, and we ended up publishing in like less prestigious model where um, they they're less strict about statistical rules. But thing is, the reason why we didn't, and the way to address multicollinearity is to drop models, to drop a variable. So let's just do this exercise for like fun. Okay, let's see. Oops. So what we are doing? Oops. Oops. So, ah, oops. Okay, let's see what happens. Oops. Addressing multicollinearity by removing, let's share young adults imputed. So we just remove it and see what happens. An important thing is when you run different models, make them like give them different names. So let's be it like P2. So you don't get like you see P1 is the object for results for our first model, right? So if we run it again, we will overrun it, and we should not do that, right? We need to create a different object. So let's do this. Okay, in terms of our like interaction variables, they're a little bit different, but they're still like statistically significant. And let's do a multicollinearity check again. Oops. Yeah, let's make it. Okay, and again, P2, it's a different object, right? So let's check. Okay. What can we what can we say now? Do we have multicollinearity? Ben, what do you think?
The by far the most problematic instance of it is gone.
Yep.
Um, I'd still still be a little worried about the multicollinearity with post and with post interacting with the STLDI 36,
Hmm.
but it's below 5, which is what you put as sort of a real problem.
Yeah, at least this is like interpretation, which is kind of common. But again, like thing is, this is how you address multicollinearity in terms of keeping statisticians happy. But the reason we didn't like drop this share of young adults are theoretical, and the theory is they're not statistical, and the theory is that share of young adults is pretty important factor for premiums because if you have a larger share of young people in your state, on average, again, not always the case, but on average, younger people tend to be more healthier. So, and this affects premiums. They utilize health insurance less. Right. At least this is what my co-authors decided. When we did this paper, I was a PhD student, and one of my co-author was still is distinguished professor, and another co-author, associate professor of econometrics. He's not even economist; he's econometrician. So they decided it's like theoretical reason for a variable is more important than statistical reason. Okay, that's about it, and I will make sure I will upload this updated version to Canvas for your future reference. And let's see what happens on Wednesday in terms of rain. Okay, let me. Okay, boom, boom. Okay, stop.